Hello and welcome as we take up a quick fire maximization question using Simplex. So, up till this time we have taken questions with two constraints and two variables. Yes, there have been certain situations where we have taken three constraints with two variables. But today we will try with three constraints and three variables. So, we have three variables as x, y and z decision variables. So, this is the question and we will try to solve it using Simplex, and let us see if our Simplex method is all that much complex. Now that we have been through certain questions of Simplex, probably we know this algorithm, we know the sequence, we know the steps. So, let us practice this question in a rapid fire state. Quickly we will go through this question. So, our first step is converting the canonical form into standard form. How do we convert it into standard form? We convert it into standard form by removing these inequalities. How so? 2x plus 3y plus 4z. This is less than, so there will be a slack, addition of slack. I will add something so that it becomes equal to the right hand side, making it 440. Second becomes 4x plus 3z plus S2 is equal to 470. Then finally we have 2x plus 5y plus S3 is equal to 430. So, these are our constraints converted into equalities, inequalities converted into equalities. In this conversion, while we were trying to convert the inequalities into equalities, we have introduced three more variables. We started with x, y and z as decision variables, z as key variable. Now I also have slack variables. So, I need to incorporate these slack variables also into my objective function, because objective function should represent the complete picture of all variables. Right now my objective function is presenting a picture of only x, y and z, relationship of only x, y and z. But I am making use of certain more variables now, slack variables. So, I need to include these also into my objective function. How do we do that? Z max is equal to 4x plus 3y plus 4z plus 0 into S1 plus 0 multiplied by S2 plus 0 multiplied by S3. X, y and z will be greater than or equal to 0. This is my standard form. So, from canonical, I have converted my problem into standard form. Next is find IBFS. What is IBFS? IBFS is determined by substituting all decision variables and surplus variables as 0 in constraints. Decision variables and surplus. We are not making use of any surplus variables because surplus variables come when we have a greater than type inequality. For now, we are having all as less than type inequalities. So, we will not be having surplus variables. So, I will put x, y and z equal to 0. So, what is my IBFS in that case? S1 is equal to 440, S2 is equal to 470 and S3 is equal to 430. This is my IBFS. And making use of this IBFS, can I have my initial simplex table? We will be having S1, S2, S3. We will be having B and theta. Then there will be X, Y and Z. What are the contributions? Now we are having a space crunch over here, so I will make use of some other color, otherwise it will mix. So, contributions are 4, 3, 4, 4, 3, 4, 0, 0 and 0. Let me check the contributions 434. Sorry, these contributions as given in the problem were not 434, rather they were 436. So I'll make this update. It's good that I checked 436. 436. Contributions are 436 instead of 434. Let me check this problem once again. 436. Then we have a 232. This is a 232. I believe there is something wrong. This is 232 instead of 234. Right. So we have 436, 232, there is a 4, 3, then there is a 2, 5, we have 440, 470 and 430. So this is the problem. 232, 232, 43, 25, everything has been updated. These were some errors. Now let me prepare my first initial simplex table. Initial simplex table would be IBFS S1, S2 and S3 having values of 440, 470 and 430 with their respective contributions of 0, 0 and 0. Contribution of S1, S2 and S3 is 0 only. What do we have over here? We have a 232, 232, 100. Then there is a 43. Now remember y is missing from here. So we'll be having a 403. 40. Last constraint is x and y are there and z is missing. So I have a 250. As for slack constraints, slacks, this becomes my initial simplex table. And now we can even start our calculation from this initial simplex table. We have Cj's and we have Zj. Zj is sum product of respective A's with their contributions, respective column with its contribution. So it will be 0, 0, 0, 0, 0 and 0. Then being a maximization problem, I need Cj minus Zj. Cj minus Zj would give me 4, 3, 6, 0, 0 and 0. So I have my key column as Z. Z is my incoming variable because it is the most positive. And then in theta I need to check for least positive. How do we check for theta values? Theta values will be 440 divided by key column. 440 divided by 2, that is 220. 470 divided by 3, it will be, and then we have 1 and 7, 156.66. Then this will be 430 divided by 0, that is infinite. So this is my key row. So I have my key row and key column. This is my key row. This is my key column. This is key element. So I have my incoming variable as Z and my outgoing variable will be S2. Now can we prepare our second matrix, second simplex table? Second simplex table would be X, Y, Z, S1, S2, S3, B, and then you can have theta also. Contributions are 436, 436, 0, 0, 0. S1 and S3 are here only, but S2 will be replaced by Z. So we have S1, Z, S1, S3 are still intact, but S2 has been replaced now by our incoming variable key column. Now it is suggested that you pick up your copy and pen. You also write down this problem, pause the video and check if you are also getting same values, because now we'll be transferring the elements. Now if you remember, what were the formulae? What were the formulae that we were making use? I'll put it over here, let's say. The formulae were, first one was for all key row elements divided by key element. First is for key row, all key row elements will be divided by key element. Second rule is for all other rows. What is that? That is old row I minus key column element I multiplied by modified key row will give me my new row I. So these are the two formulae that we'll be making use of in transferring the elements over here. So what are the contributions? S1 would be 0, Z would be 6 and S3 would be 0 again. Fine. Now let us transfer this key row. Key row after being divided by key element. So it will become a 4 by 3, 0, 1, 0, 1 by 3, 0 and 470 by 3. We'll leave it as 470 by 3. So I have transferred my key row to my new matrix. What about the first and third row? I'll make use of this formula. This formula becomes old row 1 minus key column element 1 multiplied by modified key row is equal to new row 1. New row 1 will be brought from here using this formula. What is the row? 232. Old row is 232, 100 and then there is a 440 minus key column element I, key column element 1, key column element 1 multiplied by modified key row. This is my modified key row. 4 by 3, 0, 1, 0, 1 by 3, 0, 470 by 3. What do we get? We'll get a 6 minus 8 minus 2 by 3. This will become 3, this will become 0, 1, this will become 440 multiplied by 3, 0, 3 fours are 12, 3 fours are 12 and 1 13 minus, this will be an 800, 940. So you'll get a 0, then there will be 12 minus 3, 12 minus 9 would be 3, 380 by 3. So we are getting, I'll just confirm it, we are getting minus 2 by 3. I've solved this question, so I'll just tell it with this. Minus 2 by 3, then there is a 3, 0, 1 minus 2 by 3, fine. This is exactly what we are getting. Minus 2 by 3, 3, 0, 1 minus 2 by 3, 0, 380 by 3. This was transfer of first row. Now I need to transfer my third row. Now I need to transfer my third row. What is my third row? My third row is 25001. 25001 and last one is 430 minus old row minus key column element. This time we are transferring third row, so everything becomes 3. Key column element 3. Key column element 3 is 0. What more can we expect? So all these terms become 0. So literally what is transferred? The same values are transferred exactly because all this becomes 0. So what do I get? I get a 25001 and 430. These are my contributions. Here is my Zj. Zj, all these will be multiplied to 0, so they become irrelevant in my sum product. All these will be multiplied to 0 at some point of time, so they become 0. So this multiplied by this multiplied by this, plus this multiplied by this. So these two are irrelevant, only living term is this. And this becomes 28. 06020. So Cj minus Zj would be 4 minus 8. Minus 4. 3, 0, 0, minus 2 and 0. So if I look at net evaluation row, what do I get? Negative, negative, zeros, there is a positive, so this becomes my key column. And dividing the B by key column, I will be getting my thetas. So 470 divided by 0, it will be infinite. 380 by 3. 380 by 3 divided by this 3, making it 380 by 9, making it 9 4s are 36, 2, 9 2s are 18, 42.2. This will be 430 by 3, 430 by 5, sorry. 5 8s are 40, 5 6s are 30. So this is the least positive, giving me my key row. So now can I mark my key rows? Key row, key column and key element. Remove this. And we'll prepare some space for our next matrix. We'll make our next matrix, let's say over. We'll make our matrix over here and do the calculations there. Yes, please check if the identity matrix is intact. S1 is 1, 0. S2 is 1, remaining is 0. S3 is 1, remaining is 0. So first was correct, second S1 is 1, remaining column is 0. Z is 1, remaining column is 0. S3 is 1, remaining column is 0. So it looks like I'm on right track. There might be errors, but on the face of it, I do not see any errors. So I have X, Y, Z, S1, S2, S3, B and theta. Contributions are 436,000. S1 is outgoing variable, Y is incoming. So S1 will be replaced by Y, remaining two are same, that is Z and S3. What are the contributions? Y is 3, Z is 6, S3 is 0. The two rules are all key row elements are divided by key element. All key row elements are divided by key element. So minus 2 by 3 divided by 3 would make it a minus 2 by 9. Minus 2 by 9. Then there is a 3 divided by 3 would be a 1, 0, 1 by 3. Again a minus 2 by 9. Again a 0. And last one would be 380 by 3. 380 by 9. 380 by 3 divided by 3. 380 by 3 divided by 3. So I can say it is 3 by 1. So when I solve it, it becomes 380 by 3 and this gets flipped 1 by 3, making it 380 by 9. So our key row has been transferred. Next, let us talk of the remaining two rows, second and third row. The formula becomes old row 2 minus key column element 2 multiplied by modified key row is equal to new row 2. Old row 2, 4 by 3, 0, 1, 0, 1 by 3, 0. 4 by 3, 0, 1, 0, 1 by 3, 0, last one is 470 by 3. So, key column element 2, key column element 2, it is 0. Multiplied by modified key row. Modified key row is, this one is modified key row. Minus 2 by 9. Minus 2 by 9. 1, 0. 1 by 3. Minus 2 by 9. 0. 380 by 9. What do we get? All these are being multiplied to 0. 0, this becomes 0, so I get 4 by 3. This becomes 0, so I get 0. So ultimately I will be getting same row because this element is 0. Or rather we can even solve it, no issues. If you solve it, you will get a 0, making it 4 by 3. 0, 1, 0, 1 by 3, 0 and 470 by 3. So what I get is 4 by 3, 0, 1, 0, 1 by 3, 0 and 470 by 3. Then we need to transfer the third row. So for third row, what we do is, for third row, we have 2, 5, 2, 5, 0, 0, 1, 1, 2, 3, 0, 0, 1 and last one is 430. Minus key column element 2. Key column, sorry, we are talking of third row. It is third row. So key column element 3. It will be 5, 5. You should pause this video and solve this for yourself so that we can tally if there is any difference between your readings and these solutions. So 5 minus 5 would be a 0. This would be a 0. This will be a minus 5 by 3. Then I have a minus and minus plus 10 by 9. That is a 1. This will be 9 times. 9 3s are 27. 9 4s are 36, 38. Minus this thing. 5 8s are 40, 5 3s are 15 and 4 19 upon 9, making it 70, 1970 by 9. 1970 by 9. So what do I get? I get a, this one I have not solved. This will be plus. So 9 2s are 18, 18 plus 10, 28 by 9, 28 by 9. Then there is a 0, 0, minus 5 by 3, 10 by 9, 1 and 1970 by 9. I have my CJs, I can have my ZJs. I will remove all these unnecessary things. Even we can remove this. We need to multiply these and add. So this will become a minus 6 by 9. Then there is a plus 24 by 3. This can be written as 2 by 3. So I get 22 by 3. 22 by 3. This will be 3. This will be 6. Then we'll have a 1 plus 0, that is 1. And there will be 3 into 2, making it minus 6 by 9. This will become 6 by 3, minus 6 by 9, 6 by 3. Let me make it 2 by 3. So we have a minus 2 and 4, 4 by 3. This is straightforward 2. This is, something is wrong. This is minus 6 by 9 and this is 6. Acha, this is subtraction. Okay, so this is 2 and this is a subtraction of, correct. Finally we have a 0, Cj minus Zj. 4 minus 22 by 3, making it 12 minus 22, minus 10 by 3, 0, 0, minus 1, minus 4 by 3 and 0. So now we see that all values are either 0 or negative. All net evaluation row values are either zeros or negatives. So I can say that finally I have reached my best possible solution. And best possible solution is y should be equal to 380 by 9, while z should be equal to 470 by 3 and x is not featuring in the final solution. So my final solution would be, I'll write it down in some other color. Final solution will be x is equal to 0, y is equal to 380 by 9, z is equal to 470 by 3, making z max is equal to 4 into 0 plus 3 into 380 by 9 plus 6 times 470 by 3. You can cancel this down, this becomes 0, so you have 0 plus 380 by 3 plus, if you multiply this, you will get 642, 28 by 3, making it 003820, making it 2900, 3200. This is my solution. My solution for the given problem is that x is equal to 0, y is equal to this, z is equal to this, will give me a z max of 3200 by 3. So this is our solution for given maximization problem. Now if you have any doubts regarding any of these values, or you have any other doubts from your books, from your course, you can leave them in comment box. So this was it for our today's lecture. Thanks for watching. Bye bye. Take care.